Hey students, it's now time to take Test 4, which is our last proctored exam in online college algebra. Question number 4 asks you to find the domain of a function. If you recall, the domain basically is all real numbers or negative to positive infinity except if it's a fraction or a square root. Since this does not have a fraction or square root, the domain would be negative to positive infinity. Another domain question that deals with a fraction where the fraction has the denominator of x squared minus 81. Remember, you never want a zero denominator, so avoid zero denominators. That means we need to figure out which numbers should we avoid for this domain. What you can do is take x squared minus 81 and factor it as the difference of two squares and ask yourself, where would that equal to 0? Well, if you think about it, that would be where x is 8, because 8 minus 8 would give you 0, and x would be negative 8, because negative 8 plus 8, 0. That means every number in the world, every number on the number line except positive 8 and negative 8 can be used in this domain for the x. That gives us 3 sections of a number line shaded. Every number from negative infinity to negative 8 combined with every number from negative 8 to positive 8 combined with every number from positive 8 to positive infinity. So my domain is answer B. Excuse me. Now I'm asked to operate on some functions. I'm given 2 functions and I want to find f minus g, which means to subtract. You can tell which operation by the symbol. So f minus g would be the f function, 3x minus 3, subtract the g function, 6x minus 6. I like to put these in parentheses just to keep my terms connected. Now I can remove the first parentheses, 3x minus 3, but if I'm subtracting, that subtraction sign will distribute using the distributive property to the second parentheses, and that leaves me minus 6x plus 6. Now I will simply combine my like terms. So 3x minus 6x is a negative 3x, and negative 3 plus 6 is a positive 3. That would be my solution, and negative 3x plus 3 is answer choice D. Now I'm asked to operate on 2 functions that are set up as a fraction. This is like my favorite one, because when you have to find a fraction between 2 functions, you simply must put the correct one on top and bottom of the fraction. So the f is on top, that would be 8x squared minus 9x. The g function should be on bottom, and that's x squared minus 3x minus 54. So my function would be answer choice C. Now we want to find f plus g. F plus g would simply mean to add. So I will have f plus g. F is x minus 8x minus 6x. Then I will add negative 4x plus 6. Since it's addition, there is no sign change. So I take these terms. That was 8 minus 6x. I'll get it right here in a second. And negative 4x plus 6. Combine those like terms, and that will give me negative 10x because I combine my x terms, and then plus 14. That would be my solution. Also, if you recall, sometimes you will be asked the question, what is the domain of this new combined function? Remember, the domain rule is it's always negative infinity to positive infinity unless you have a fraction or a square root or some type of even root. In that case, you need to avoid a zero denominator or an imaginary number. Now in this problem, we have FG, so that means to multiply. When I multiply f times g, I have 9x minus 8 times 5x plus 2. This is a great time to remember the FOIL method. First, outer, inner, last. So we need to multiply. First terms would be 9x times 5x. And 9x times 5x is 45x squared. Next, we would multiply the outer edges of each parentheses for the O. 9x times 2 is 18x. Thirdly, we multiply these two terms that are innermost. Negative 8 times 5 is negative 40 with the x. And last but not least, we will multiply the last numbers in each parenthesis. Negative 8 times positive 2 is negative 16. After you multiply using the FOIL method, be sure to combine your like terms, which normally result in the middle. So my answer is 45x squared minus 22x minus 16, which would be answer choice B. Now in this question, you will not have a multiple choice, but you'll need to work out each part. Part A is f of g of x. That is the composite function. That literally means we take g of x and we substitute it inside of the f of x. So I'm going to take the g of x, which would be these terms, x squared minus 2, and I'm going to plug that inside the f of x. So that will give me 3 times x squared minus 2 and then minus 5. Notice the x squared minus 2 replaces the x in that first function. Then I will work it out. So it will be 3x squared minus 6 minus 5 using the distributive property. Combine like terms, and I get 3x squared minus 11. My first answer I would type in 3x squared minus 11. Now, for part B. Part B is g of f of x, so the order changes. This literally means f of x will be substituted inside of the g of x. It's going in the opposite direction of part A. So I go over here and take the f of x terms and I plug that in for the x in the g function. So instead of x squared minus 2, I have 3x minus 5 squared minus 2. Notice again the first function in this case substitutes into the x of the other function. Now when I simplify, I have to remember that 3x minus 5 is squared. So I would do the FOIL method, and after I do the FOIL method and combine like terms, I would get 9x squared, and then negative 15 is negative 30x plus 25, and then I bring down the minus 2. When I simplify this last answer, I end up with 9x squared minus 30x plus 23. That would be my answer to type in for the second part. 9x squared minus 30x plus 23. Notice part A and part B answers are very different in their appearance. Now when it comes to part C and D, this will be easier. Part C wants to know what is f of g of 1. So go back to part A, and if you want f of g of 1, notice part A used the FOG. So you will just plug the 1 into the answer you had for part A. So 3 times 1 squared minus 11, that ends up being 3 minus 11, which is a negative 8. So the answer for part C is negative 8. Now part D takes g of f of 1, and remember the GOF was the B problem. So you will take the 1, substitute into the answer you got for part B, the one that was GOF. When you work this out, you end up getting 9 minus 30 plus 23, which is equal to 2. So that would be my answer. On question 8, you are asked to find the inverse function. Remember, to find the inverse function, you will first write the problem using a y. So instead of f of x, replace f of x with the letter y. After you do that, you will reverse the x and the y. So rewrite the problem as x equals 7y plus 2. Then the last step is to solve for y. Now, since y has now become part of the problem, mixed up in on the right-hand side, I solve. So I will subtract 2 on both sides of the equation, which leaves x minus 2 equals 7y, and then I divide by the 7. So y is equal to x minus 2 over 7. This y is actually my f inverse function. So what you will do in my math lab, you just have to type in that fractional portion. The x minus 2 over 7 should be typed into the answer box. On question 9, it's another inverse function. So remember, step 1 is just to replace the f of x with the letter y. Then step 2 is to reverse the position or the location of the x and the y. Now step 3 is to solve for the y. So the first thing I need to do is take the cube root of both sides so that I can get that y term out of that parentheses. Then I would subtract 8. So y is equal to the cube root of x minus 8. And remember, that is the f inverse answer. So you would need in this answer box to type in cube root, don't forget the cube root, of x minus 8. And that is your solution. For question 10, we have to find the inverse. Again, if you work this out on some scratch paper, step 1 is simply to rewrite the problem using the letter y instead of that f of x notation. Step 2 is just to reverse the x and the y in the problem. This one happens to be very similar to my previous example, so I would take the cube root on both sides. That would allow me to be able to drop out that parentheses. Then I would subtract the 2. So my inverse has to be cube root of x minus 2. That is the f inverse. So that's what I need to look for, and the cube root of x minus 2 would be choice A. On question 11, we have to find if the graph of a function would have had an inverse. If you recall the vertical line test that we did for functions, this would be the horizontal line test. We would use the horizontal line test to see if a function has an inverse. If I draw a horizontal line through this semicircle, you see how it crosses at 2 points? If it crosses at more than 1 point, then no, it would not have an inverse. So it must only cross at 1 point on the graph to have an inverse in the horizontal line test. Here is another one for horizontal line test. If we draw a horizontal line through this function, I can draw it in such a way that it crosses the graph in 3 places. That would not have an inverse, so no. Now on question 13, you're asked to find the distance between a pair of points, which will require a formula. The formula will be given to you on the proctored exam. The formula is this: distance equals x2 minus x1 squared plus y2 minus y1 squared. And that's where you start off with 2 ordered pairs, x1, y1 and x2, y2. Now what I normally do is label my numbers. So the 4, 4 would be the x1 and the y1. So I would go ahead and plug in a 4 everywhere there's an x1 and everywhere there's a y1. Plug in the 4. Use the rest of the symbols the same as the formula. Then I would label the second ordered pair as x2, y2. So my negative 8 is going to be the x2, and my positive 9 is going to be the y2. Now I just simplify. Inside the first parenthesis, I get negative 12, which will come back and be squared. Inside the second parenthesis, I get 5, which will come back and be squared. The square of negative 12 is 144. The square of 5 is 25, which all of that gives me square root of 169, which is exactly 13. So my answer choice is D, 13. On question 14, you would just replicate what you did on the previous problem. So remember, it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and you take the square root of all of that. So I label my first ordered pair as x1, y1. In the formula then, where there's an x1, I will put a negative 7. Where there is a y1, I will put a 4. Then I will label the second point as x2, y2. So 7 will be the number for the x2, and negative 6 will be the number for the y2. Now notice I have a double negative right here with the 7s. So that's really 7 plus 7 squared, or 14 squared. Then negative 6 minus 4 is negative 10 squared, which would end up being 100. So when I square 14 squared, 14 squared is going to be the 196, and negative 100 squared is 100. So I end up with the square root of 296. Now that's not any of these solutions, so I'm going to need to simplify this square root. And I'm going to demonstrate how to use a factor tree to simplify a square root. We're going to take the 296 radicand, and we're just going to start dividing it by smaller numbers and move up the line. So I'm going to divide this 296 by the number 2. So that would be 2 times 148. Then I will divide the 148 by 2, which is 2 times 74. Then I'll divide the 74 by 2, which would be 2 times 37, and 37 is prime. When you're working a square root, you are looking for a base that multiplied times itself. So notice that I have two 2's. In that case, I can take that outside of the radical symbol, and it would leave a 2 and a 37 underneath the symbol, because I don't have two of a kind, two matching numbers. So I multiply those back together, they become 74. The answer would be 2 square root of 74. On number 15, you'll have to use a different formula. In this case, it would be the midpoint formula. Again, all formulas will be provided for you on the proctored exam. The midpoint formula looks like this. You will take x2 and you will add x1, dividing by the value 2. Then you will have y2 plus y1 divided by 2. It will be helpful to label the numbers in the ordered pair. So that would be x1, y1, and this would be x2, y2. So if I plug the numbers in for the appropriate place in the formula, x2 is 2. x1 is negative 10. y2 is 1. y1 is 3. Now I will just simplify. 2 plus negative 10 would be negative 8. 1 plus 3 would be 4. Negative 8 over 2 is negative 4. 4 divided by 2 is 2. So my midpoint, you would type in using the ordered pair, would be negative 4 comma 2 in parentheses. Now number 16 uses still yet another formula. It is the equation of a circle. So the equation of a circle is given by the formula x minus h quantity squared plus y minus k quantity squared equals r squared. Now if you recall, the r is the radius of a circle, and the h and the k stand for the x and y in the center point of the circle. So for this problem, the 6, 0 will be the h and the k. The r is the 5. So I will take my formula again. Let me just simply recopy the formula as it is given, and I will substitute in these numbers. So I bring down everything, but in place of h, I put a 6. In place of the k, I put a 0. And in place of the r, I put the 5. Now I can simplify just a bit. This turns out to be x minus 6 squared plus y squared equals 25. So that is the equation of this circle, and that would be answer choice C. On number 17, you are given the equation of circle, and you must go ahead and pick out the center and radius so you can tell which graph is correct. If you notice the 36, that is r squared. So we will take the square root of both sides, so the radius is 6. Then if you notice the numbers given, that would be a 2, that would be a 4. Notice I'm taking the opposite sign because the formula does use a negative standing for opposite. So the center is 2, 4. Well, if I look on my graph at positive 2 and then 1, 2, 3, 4, that should be the center of my circle, but it's not right on my first choice. So I'll go over here, 1, 2, 1, 2, 3, 4. That is indeed the center of my circle, and the radius would be correct as well. If you choose the correct graph, then that will automatically have the correct domain and range listed. On number 18, we have to put together the formula for the circle, the standard form. Again, recall that's x minus h quantity squared plus y minus k quantity squared equals r squared. And this time r is a square root, so it will look something like that. The h and the k are 2 and 5 respectively. So I will substitute in a 2 for the h. Then I will come down here and substitute in the 5 for the k. Simplify a bit to get x minus 2 quantity squared plus y minus 5 quantity squared equals 3. Because if you recall, when you square a square root, that symbol is out of there. So this is what you would type in for the answer. Number 19 asks us to complete the square and then write this equation in standard form. To complete the square, we would need to draw a line down the middle of this long polynomial on the left-hand side. So think of that as x squared minus 6x plus 9, a bit separate from the y squared 10y plus 25, and then that equals the 64. What we will do next is we will factor both halves of that polynomial on the left. First, using the x, I know this would be x minus 3 times x minus 3, because negative 3 times negative 3 gives me positive 9, which really is x minus 3 squared. Then for the y value, that's y plus 5, y plus 5. 5 times 5 is 25. 5 plus 5 is 10. It verifies. That would be y plus 5 squared. And then that's equal to 64. So looking for the correct answer, I would need also to make sure that the center point is listed correctly. The center here would be positive 3, negative 5. Remember to take the opposite sign. And the radius is the square root of 64, which is 8. Notice C and D, those don't have the right radius. And then question A is the only one with the correct center and the correct form of the line. Last but not least, we need to complete the square once again. Now in this one, we're going to need to rewrite the terms a bit. See how you have a couple of x terms? Let me go ahead and rewrite those terms together. X squared minus 14x. Then I'm going to go back and pick up the y terms. So I'll put plus y squared plus 14y and put that equal to that negative 17. What I'm going to do here is need to introduce or add in a certain number to make this be a perfect square to factor. So if you recall, you will take half of this number. So take the x coefficient, divide it by 2, gives you a negative 7, then square that negative 7 to get 49. So 49 is what I add on to that x terms, and I have to add that on the right hand side of the equation to keep the equation balanced. So basically now what I have is x squared minus 14x plus 49, which will factor as x minus 7, x minus 7. Negative 7 times negative 7 is 49, which is x minus 7 squared. That's exactly what I need. I will do the same process with the y terms. So I take the positive 14 here and divide that by 2 and get positive 7. Then positive 7 squared also gives me 49. That may not always be the same number as in this example. So I add the 49 to the y terms. I have to add another 49 on the right to keep the equation balanced. So I have y squared plus 14y plus 49. That will factor as y plus 7, which ends up being y plus 7 quantity squared. Then when I combine the negative 17 plus the 49 plus the other 49, I end up with the number 81. So the radius would be 9, and the center point is positive 7, negative 7. Again, remembering to change those signs. So I'm going to look for x minus 7 squared and y plus 7 squared equals to 81, but the center has to be 7, negative 7, and the radius 9. This one's kind of tricky because B and D look similar, but that's it. 20 questions on this tutorial homework to work out, and there will be 20 questions just like this on the proctored exam. You can go back and do similar exercises on this tutorial if you want to. Just kind of keep working the tutorial, and I'll take the best grade on whatever tutorial attempt that you have. Good luck on that. Remember, the formulas will be provided at the proctoring test, and if you have any questions, just contact me.